We've converted from vertex form to standard form, but now let's learn how to convert from standard form to vertex form. So remember, standard form is ax squared plus bx plus c, and we're trying to make it look like vertex form, which is a times x minus h squared plus k. Now, the benefits of converting to vertex form are a handful of things. One, we can see the vertex. Remember, your vertex is h and k. The other thing is we can see the transformations. Remember, each letter A, H, and K all had their own transformations. We can see the max and the min value, which is that K value, remember. And those seem like pretty good benefits depending on what your question is. Oh, the last one, your axis of symmetry. Remember, that's the H value or the X value of your vertex. So let's look at these steps. Let's go through these things together. So the first step wants us to identify the A, the B, and the C value of our quadratic. I'm just going to label them above my equation. Those are my A, my B, and my C value. Now, in vertex form, a really big part of it is the vertex. So we want to use this vertex form equation, that opposite of b over 2a. Remember, you use this when we graphed in standard form. So I'm going to write off to the side here, x equals the opposite of b over 2a. So that is the opposite of 8, which is a negative 8, all over 2 times 1. So it's going to be negative 8 over 2. So x equals a negative 4. Okay, the x value of my vertex is equal to a negative 4. Before we get into step C, I want to talk about a vertex template, how we're substituting these things in. So remember, your vertex template has an x minus something squared. That's the outline. That's the thing that's not going to change. So I just found the x value of my vertex. That was a negative 4. How can I find the k value? Well, the k value of your vertex is the y value. So we want to substitute x into our equation. So I'm going to move a little bit down here. I'm going to say f of negative 4, because we're substituting in for x, is equal to a negative 4 squared plus 8 times a negative 4 plus 1. So you can do it by hand like I'm doing now, or we can put it all in our calculator at one time. So if we put it in our calculator at one time, we would say negative 4 squared, make sure it's inside parentheses, plus 8 times a negative 4 plus 1. And I get a negative 15 back as well. So that's the k value of my vertex. That's what goes out back. Okay? Now, if we notice, we have one more spot left to fill. We have this A spot. The A spot is the same. This A value and this A value represent the same thing. So looking at our quadratic equation, that A value is 1. So I could write a 1 out here, but that's kind of understood. It's not necessary. However, we could clean up our equation because what's minus a negative? A positive. So this vertex form is going to be x plus 4 squared minus 15. And that's the final answer there. Let's look at 11, and then I'll have you practice 10 and 12. So let's notice what letters we have here, A, B, and C. We want to find the vertex, so I'm going to use this vertex form equation. So I have the opposite of b, so the opposite of a -6 is a +6, all over 2 times a. My a value is 3. So I'm going to have 6 over 6, so x equals 1. Again, let's go back to this vertex equation. So this template we have here, squared. I found the x value, that h value of my vertex, so I'm going to substitute it in. I need to find the k value, so I'm going to substitute that into my equation. So f of 1 is equal to 3 times 1 squared minus 6 times 1 plus 5. So 3 times 1 minus 6 plus 5, 3 minus 1 equals 2. Again, you could type all of that into your calculator. 3 times 1 squared minus 6 times 1 plus 5. 2 is the right answer. So that's the k value of my vertex. I'm going to put plus 2. That 2 is positive, so I put plus 2. Now the a spot, that gets a 3 here. I have -1, so I don't have to clean anything up. This is going to be my vertex form equation. So go ahead and pause the video and try examples 10 and 12, and then check back for. Welcome back. I hope you paused the video to truly try questions 10 and 12 by yourself. Here's my work and the final answers. I do want to do a couple examples on your practice page just so you're comfortable with what you're doing. So in your packet, flip to the next page, page 13. So the first 5 questions, they're all in standard form. And you're going to have to convert them to vertex form in order to identify the axis of symmetry and the vertex. So the first step here, I'm going to say convert to vertex form. And then step 2, I'm going to say state axis of symmetry and the vertex. So remember, to convert, we need to be able to find our vertex. So we're going to use the opposite of b over 2a. So this is going to be a -4 over 2 times 1. That's -4 over 2. So x equals a -2. So we'll subtract 2. We're going to have to find the y value of our vertex. I'm going to just quickly use my calculator for this because I don't have very much space to work. I'm going to get, so -2 squared plus 4. Okay. So that's also -2. And my a value is 1. So if I were to clean this up, x plus 2 squared minus 2. So this is my vertex form. So from this vertex form, you are able to find the axis of symmetry and the vertex. Your vertex is -2, -2. Your axis of symmetry is x equals -2. Remember, your axis of symmetry is always the x value of your vertex. Another good idea while you're practicing here is to remind yourself of some of these transformations. So I'll write a transformation review on some of these problems just to remind yourself of some of these skills that you've previously learned. So one transformation is we're headed to the left 2, and the other one is down 2. Left 2 and down 2. You'll finish this page front and back. On the back, however, there's a few questions that are already in vertex form, so you do not have to convert. Happy practicing!